Space-minded disruptions. Good afternoon, ladies and gentlemen. Thank you to the National Gallery Victoria for inviting me here and providing an opportunity to speak my mind on space. I have recently finished a fantastic 40-year career in the Royal Australian Air Force, which provided me with many diverse educational and operational experiences, including thinking about space. In my last job, I had a go at some futurist thinking to explore the risks of future disruptions, including space, and how they may change the ways that we are doing business today. Of course, disruption is something that requires a business to change and adapt in order to continue to be a viable business. The Industrial Revolution's framework. We use a framework, such as this, to describe the revolutionary step changes that have disrupted industry throughout our history. If industrial powers failed to embrace disruption, they would likely become inefficient, less competitive, economically non-viable, and obsolete. Germany has identified Industry 4.0 as the latest disruption. The realization of cyber-physical systems enables us to achieve better and deeper levels of situational awareness of the inner workings of machines on a micro scale. Industry 4.0 designs enable a business to be better informed on its work productivity and to be rapidly agile to transform business in response to disruptive changes in the business environment. Where Industry 4.0 exploited the micro views to do better work, maybe we might consider space as a disruptor that exploits the macro views of the universe to revolutionize the ways for industry and services to be more successful. Industry 5.0 Space-mindedness. Only a few spacefaring nations and large companies can afford to own the technological capabilities to access space readily. However, it is not the ownership of space technology but an understanding of its applications that is the disruption. I call this space-mindedness, and this is the disruptor. Space-mindedness enables the augmentation, extension, and globalization of not only the large multinational global companies but also individuals and small businesses. It is a disruptions that should be seen as the next industrial revolution. Where Industry 4.0 enabled us to look inside into the micro world of businesses to do work better, space allows us to access the macro world to do work better, globally. Space is the high ground advantage for mega access and control. Space provides a high ground advantage to extend and expand beyond our earthbound physical limitations for reach, observation, access, communications, and control. The space advantage is not limited to just looking over the horizon but now provides a person with access to a global perspective and a global reach for influencing and controlling activities on the ground. The good thing about the space advantage is that it connects different people, organizations and economies that were previously segregated by geographical boundaries. The maybe not so good thing is that space is impervious to geographical borders and some sovereign powers are concerned for the loss of their abilities to control access and influence within their sovereign borders. Space-mindedness enables industries to see more in more detail, to access more, to control more, and do more, all with lesser effort. Boyd's OODA loop, observe, orient, decide, act, provides a useful decision model to explain how space is changing business on Earth. Smart agriculture is an example of how space can be integrated into a business to make business better. Space is augmenting human abilities to observe more, understand better with a history of Earth observations, make smarter decisions, and reach further to influence and act faster, and for longer. Agriculture 4.0 integrates farming with remote sensing, internet, satellite communications, Internet of Things, and position, navigation and timing. Observe, remote sensing provides perspectives ranging from the macro-scale global perspectives to micro-scale spectroscopic signatures that indicate the presence of individual chemicals. The detection of chemicals and water enables the health monitoring of soils and plants. Cyber-physical systems can use Wi-Fi and satellite communications to provide live data on the moisture content of soils and individual plants. Satellite communications and global navigation satellite systems enable the farmer to understand the situation of the farm, down to 10 centimeters resolution without needing to travel away from a handheld computer. Orient, the aggregation of multiple observations over time provides temporal analyses to study climates, better understand climate changes and their impacts on agriculture, including determining the best dates and locations for farming activities. Decide. Studying the histories and statistics of global farming phenomena enables the farmer to consider options and make comparisons with the techniques that have been successful for others in similar situations elsewhere in the world in previous seasons. Act. The high ground advantage enables global communications for the farmer to be able to reach out and remotely control multiple activities, concurrently, and beyond the horizon. Remote control system and space connectivity can extend the ranges of human actions beyond the horizon on Earth and off Earth out to the limits of the solar system. That is, consider the NASA Voyager 1 and 2 deep space missions. Can Space 2.0 transition to Space 3.0 in space industries? Within the space history, Space 1.0 describes the period when only governments could afford space missions, using very large and expensive satellites. Today, Space 2.0 has made it cheaper to access space and perform space missions using smaller and less expensive satellites. Potentially, the next disruption in the space industry, Space 3.0, could be pushing the business of space off the Earth and into space. There could be many possible drivers for space-based manufacturing and services. Remove. Some Space 1.0 satellite designs were not meant to be reused or orbited. They are choking up useful orbital trajectories and pose an uncontrollable collision hazard to other satellites. We can remove these substantial debris hazards by using space tugs. The space tugs fly to a rendezvous point, grapple the target satellite and then push it out of the popularly used orbital altitude, either up into a graveyard orbit or down to burn upon re-entering the Earth's atmosphere. Recycle. The first satellites were built with a known mission life that was based on the fuel available for maneuvering to maintain their orbital trajectory and position. The mission ended when the fuel reached the minimum reserve needed to perform one final maneuver under orbit the satellite, to make way for any replacement. The electronics on these dead satellites may be reusable if a space tug could rendezvous, dock, and then use its propulsion system to maneuver the old satellite into a new mission. Review. Inspector satellites could be used to rendezvous and inspect satellites in orbit. There are plenty of expired satellites and satellites on orbit that failed for unknown reasons because of communications failures that might be useful to harvest and recycle. Inspector satellites provide options to review the reusability of expired and damaged satellites. Repair. It may be a better investment to repair some satellites in orbit rather than invest in launching a replacement. Robotic servicing satellites could be useful to rendezvous and dock with a damaged or expired satellite to perform on-orbit repairs. Reconfigurable. Orbiting satellite bases could enable manufacturing and launches in near-zero gravity conditions. Software reconfigurable components would make it possible to assemble different satellite designs for different missions, as needed. The higher the launch site, the less energy is required to boost a satellite into space. This concept can also provide a staging base for assembling and pushing out satellites and large payloads that are too heavy to launch from the ground, especially for interplanetary missions. Recover. Some venture capitalists are considering spacecraft and rendezvous missions for capturing and recovering small asteroids for mining in Earth orbit. Microgravity manufacturing. The microgravity environment offers benefits that can disrupt traditional manufacturing techniques that are complex to do under the full force of gravity on Earth. For example, terrestrial latex versus space latex. Here are two images showing the latex manufactured under gravity, on the left, and in the microgravity of space, on the right. Microgravity makes it easy to produce spherical objects more orderly, consistently and efficiently. These techniques will also benefit the manufacture of steel ball bearings, pharmaceuticals, electronics components, and quantum technology. Harvesting off-Earth resources, energy, and mining. Industrial techniques and experiences in mining and extracting minerals and resources gained on Earth may be migrated to space to harvest off-planet resources on the Moon, asteroids, and other planets. We have developed remote sensing techniques that have been developed and easily validated on Earth and now applied to studying asteroids and planets. Australia has developed leading technologies for the remotely controlled and automated systems to find and extract minerals and agricultural resources, on land and sea. These experiences can be used to build new technologies and operations to harvest resources on other worlds. These technologies and operations it will also benefit off-planet activities, such as harvesting resources and energy to sustain a lunar habitat. These resources may also be recovered for use on Earth. Growth in harvesting, innovation and space. Technology that is not new can now be considered in the context of applications with and in space to generate new capabilities. Space enables business systems to see more, reach further globally, do more in depth, and respond faster to change. There is a revolution to harvest innovative thinking in industrial design, and this should include space-mindedness. Space 2.0 has made space more affordable and accessible. The race to harvest the resources in space, including orbits, is disrupting how we live our daily lives and will need to usher these lifestyles into the future. It is time to incorporate space-mindedness into business designs. Space-mindedness is disrupting traditional designs by augmenting and extending systems designs and applications from being point-to-point systems in the R&D department to being operationalized as global systems. We should now always be mindful of seeking to harvest space to exploit the space advantage. Space-mindedness requires a multidisciplinary education to understand the many unique advantages and limitations offered by space. Space-mindedness is not just rocket science and technology. Space-mindedness also involves consideration of the ethics of being able to look into your neighbor's backyard without them knowing. It is about the impact of the internet to democratize access to information and analyses, including geospatial coordinates to be able to locate anything. We need to use space responsibly and sustainably. Space-mindedness is also a frame of mind to understand the consequences of our actions in space and to use space wisely. This picture is an artist's depiction of the artificial objects that are resident in our orbital environment. It is not to scale. With the Earth rotating beneath this cloud of activity, everybody gets some exposure to everything in space. The European Space Agency uses an analogy of ships in the ocean to describe the challenges of space debris. Imagine if all the sunken shipwrecks from throughout history were still afloat. Now, imagine the effort needed to safely navigate a shipping lane filled with floating ship debris, in stormy weather. At least with the oceans, shipwrecks sink and clear the shipping lanes. In space, orbiting space wrecks remain in orbit as a legacy for future space users. Space-mindedness is an understanding that space is not an infinitely available resource. We continue to harvest space as a resource that is freely available to anyone who can access it. It is a global commons. Some orbits are more popularly useful than others. This competition increases when clean space in the good orbits are becoming harder to find with the accumulation of artificial space junk that is the legacy of over 60 years of human involvement with space since Sputnik. Space-mindedness is using space responsibly and fairly when there are no rules. We must learn to work collectively to fix an unfortunate history of our tragic use of space as a global commons. We need to recognize space is not an infinitely available resource. We need to use space responsibly and sustainably. Otherwise, the world that we have created today, that is critically dependent on space, will be disrupted. Spaceship Earth. We need to change our thinking to space disruptions and be more considerate of the consequences of our actions. In the absence of international rules to govern the uses of space, we could collectively do better with space-mindedness. We need to appreciate that we live on Spaceship Earth, a system of systems that is critical to life. It is an integrated ecosystem that includes the space environment. Space is not something that is separated from our living environment that we reach up to access, as and when needed. Space permeates our everyday life and is an embedded part of modern life. We have now integrated the resources and activities in space with our activities and resources on Earth. We need to be thinking more about the responsible and sustainable uses of space today to keep space available for tomorrow. Space is where we live. Thank you.